You're already familiar with solids like cube, cuboids, cone, sphere, hemisphere, and cylinder. Do you remember their volumes? Let us recap on the formulae for volume of solids. Take a look at this. YB is playing with his top. He says, "This is my favorite toy. It spins and it's also my piggy bank. Can you help me find how many coins fit in here?" The number of coins that fit into the piggy bank can be found by determining its volume. We can see that YB's top is made up of two solid shapes, that is, a cone and a hemisphere. So, the total volume of the top is equal to the sum of the volumes of hemisphere and the cone. Let us consider this as equation 1. We know volume of hemisphere is 2 by 3 pi r cubed and volume of a cone is 1 by 3 pi r square h. So, substituting the known formulae in equation 1, we get volume of the top is equal to 2 by 3 pi r cubed plus 1 by 3 pi r square h. What do you conclude from this? From this, we can conclude that volume of any real-life object can be found by summing up the volumes of its constituent basic solid shapes. Now, let us use this concept of combination of volumes to determine the volume of a rocket. A rocket is in the form of a right circular cylinder closed at the lower end and surmounted by a cone with the same radius as that of cylinder. The diameter and height of the cylinder are 6 cm and 12 cm respectively. If the slant height of the conical portion is 5 cm, find the volume of the rocket. Here, it is given that the diameter d of cylinder is 6 cm. So, radius r is d by 2, that is equal to 3 cm. The radius of cone is equal to the radius of cylinder, which is equal to 3 cm. We know that the volume of cylinder is pi r square h. Substituting the values of r and h, we get volume of cylinder is equal to 339.42 centimeter cube. We know that slant height of cone is 5 centimeters, base radius is 3 centimeters. Using Pythagoras theorem and simplifying, we get value of h is equal to 4 centimeters. We know that volume of cone is 1 by 3 pi r square h. Substituting the values of radius and height, we get volume of cone is equal to 37.71 centimeter cube. We know that volume of the rocket is the sum of the volumes of cylinder and cone. Substituting the known values and simplifying, we get volume of rocket as equal to 377.1 centimeter cube. Now, let us solve another real-life problem of finding the volume of this pen stand. A pen stand made of wood is in the shape of a cuboid with 4 conical depressions to hold pens. The dimensions of the cuboid are 10 centimeters, 5 centimeters, and 4 centimeters. The diameter of each of the depression is 1 centimeter and the depth is 1.4 centimeter. Find the volume of wood in the entire stand. It is given that the dimensions of the cuboidal part are 10 centimeters into 5 centimeters into 4 centimeters. We know that volume of the cuboid is length into breadth into height, that is, L into B into H. Substituting the values of length, breadth and height, we get volume of cuboid as equal to 200 centimeter cube. There are 4 conical depressions such that radius of each depression is 0.5 centimeter and depth is 1.4 centimeter. So, the volume of wood taken out to make 4 cavities is equal to 4 times the volume of cone of base radius 0.5 centimeters and height 1.4 centimeter. We know volume of cone is 1 by 3 pi r square h. Substituting the values of radius and height, we get volume of cone is equal to 1.43 centimeter cube. The volume of wood in the entire stand is equal to the difference of the volume of cuboid and cone. On substituting the values and simplifying, we get volume of wood is equal to 198.57 centimeter cube. Now, let us solve another practical problem. Sweets contains sugar syrup up to 30% of its volume. Find approximately how much syrup would be found in 45 sweets, each shaped like a cylinder with two hemispherical ends with length 5 centimeters and diameter 2.8 centimeters. Each sweet can be divided into a cylinder with two hemispherical ends. Diameter of cylindrical part is equal to the diameter of hemisphere. Since the diameter is equal to 2.8 centimeters, therefore R is equal to 1.4 centimeter. And the length of the complete sweets is 5 centimeter. The length of only cylindrical part is h, that is equal to 5 minus 2, radius of hemisphere. Substituting the radius, we get the value of h is equal to 2.2 centimeter. We know volume of cylindrical portion is pi r square h. On substituting the values of radius and height, we get volume of cylindrical portion as equal to 13.552 centimeter cube. We know that the volume of two hemispheres is equal to 2 times 2 by 3 pi r cube. On substituting the values of radius, we get volume of the two hemispheres as equal to 11.498 centimeter cube. Total volume of sweets is equal to the sum of the volumes of cylinder and the volume of the two hemispheres. Substituting the computed values of volumes, we get total volume of sweet is equal to 25.050 centimeter cube. So, volume of 45 sweets is equal to 1127.25 centimeter cube. It is given that the volume of the syrup is 30% of the total volume of sweets. Substituting the computed value of volume of 45 sweets, we get volume of syrup as equal to 338.11 centimeter cube.